Folks, what I have in my hand is an AI supercomputer. It is NVIDIA DGX Spark. It has some serious hardware in it. I'm going to go through the setup of this machine in this video. We will use Olama to download Gemma models on this computer and we'll run the inference. We'll also write code using these local models. All right, let's get started. Let's open this box. Look at this. It's a mini supercomputer. There are ports. We'll use this to connect the devices with this computer. And look at the size of it. It can fit in my hand. Okay, so this is NVIDIA DGX Spark. And there is a power cable. Okay, so that's pretty straightforward. And there is this manual here. As you can see, I have plugged the power cord in the very first USB port next to a power button. So there is this little power button that you see. When you press the button and start the computer, it is very, very quiet. You will not even realize that it is starting. Okay, so now that power cable is attached, let's attach rest of the devices. I have two monitors, keyboard, mouse. I'm going to attach all of that to DGX Spark, and the way I will do it is using the USB-C docking station. So I have this docking station where my monitors are connected via HDMI cables, then my keyboard etc. is connected. You see this Bluetooth device, and then this is my USB-C plug. So I'm going to insert that into one of these three ports. Okay, so this is how the connection looks. Now the moment I do that and I have of course pressed this button, it will be again very, very quiet. So I can see this. See, welcome to DGX Spark. So we'll go through the setup now. I pressed on get started. I see the screen now. So the language is US English. Time zone is EST. So now select your keyboard layout. This looks good. Enter, accept. Username, I will just say DP Code Basics, and let's create a password. Hit enter, continue, and it is updating now. Updates are done. Let's enter. This is running some Ubuntu based operating system. Okay, so this is my browser. It's Firefox. It's some customization of Ubuntu operating system, and then there is this playbooks that you can look at to start using your mini computer. Let's look at the specifications of this system. Here you can click on specification and this page will appear. It is NVIDIA's Grace Blackwell architecture. That is the architecture of your GPU. And it's a unified chip, which means it's a combination of CPU and GPU in one single chip. It has 20 core arms, okay, and 10 Cortex plus 10 additional Cortex with this specification. Then the tensor performance is 1 petaflop, 4-bit floating point operation. 1 petaflop is, I think, 10 raised to 15. Those many floating point operations it can do in parallel. This is humongous. When you're doing deep learning, etc., you want to do a lot of matrix multiplications, and matrix multiplications can be done in parallel, and that's why GPUs are shining. Just imagine the scale, 10 raised to 15 floating point operations it can do in parallel. It has a bandwidth of 273 gigabytes per second, which means that much data per second can be sent to GPU for the processing. 4 terabyte is the hard disk, and then these are rest of the specifications. As a next step, you can click on show apps and just click on this DGX dashboard. The dashboard runs locally, as you can see here, and it shows you the utilization of your system. So out of 128 gigabyte memory, I am running 7 gigabyte and my GPU utilization is close to 12%. The next step is to install Olama. Olama lets you download those models locally and it will let you run those models. So it is a Linux operating system. So I'm going to copy this command into my command bar, okay, and install it. After the installation is done, you want to download some models locally. If you click on models, you will see all the open models. I'm particularly interested in Gemma, which is Google's open source model. Right now the model family is Gemma 4. It has all these different variants. I will download the latest. So I will just copy this and then I can say Olama pull Gemma 4. It will take some time because it's 9.6 gigabyte based on your internet speed. The time may vary. Also, if you directly run Olama run Gemma 4, then what it will do is it will download the model and it will run it. So now let's run Gemma 4. So Gemma 4 is available locally and now Olama is running the model. Okay, so here you can ask any question. You can say, who was Patanjali? Patanjali was a founder of yoga. So this is like as if you are asking it to ChatGPT. And look at this. It is doing the inference. For the first time when you run it, it may take some time, but otherwise you see it's kind of really fast. Okay, so here it is asking in what context you are referring. I can say I want to know about Patanjali, the father of yoga. Answer it in 3 lines. And see, it is doing some internal thinking. So these are like the thinking tokens. And then it will generate the actual answer. So this is the actual answer that it generated. And when you look at GPU utilization, see right now it is this much, right? But I can ask a question. For example, write code to read a file line by. Now I'm asking it to write code. And while it is writing the code, you see the GPU utilization is going up because it is using Gemma 4 model for doing the local inference. And once the answer is generated, this utilization will go back to normal. This is one thing I don't like about AI. It generates so many different variants of the same code. But anyway, see, now code is generated and utilization is back to normal. The next step is to run local Gemma model with Claude code. Here we can run this command ollama launch Claude and it will launch Claude code with Gemma 4 as a model. But before we do that, we have to install Claude code. So you type this command, take it to your command prompt, okay, and run it. So that's gonna install Claude on my DGX Spark machine. After that, I can just say Olama launch Claude, okay. And I have created this folder called website. So you can see that I have this website folder. It's an empty folder. So let me show you. So when I was here, I just ran make dir website. Then I cd'd into it. And now I'm going to run this command Olama launch Claude. If you're running it for the first time, it will ask you for some setup, but we are done with that setup. Now let's create a static simple website for yoga accessories. Only HTML code, no backend, just a simple catalog of items. So I'm creating a static website because if I create a full-fledged website, it's gonna take a long time. I just want to demonstrate how Claude can work with local Gemma model and it can write code for you. This will save you the Claude subscription bill basically, okay? Now I'm running Gemma 4 model. You can run even a higher parameter model, okay? So in Gemma 4, by default, I have this one, but let's say if you want to run 20 gigabyte model with 31 billion parameter, you can specify this entire model string when you run that ollama launch this command. All right, our static website is ready. I can go to this folder, go to website, and here I see index.html. Look at this. My local Gemma model created this website. Our instructions were simple. You can of course give detailed specification on colors, images, etc. But this looks good, right? Like you have the catalogs. This is what we asked for. There is about us section, contact. I think catalog and homepage is what it has implemented. So this was a quick demonstration of how Claude Code can be used with the local models. This way you're not paying for API bills. If you have a higher parameter model which is very accurate, then you can generate infinite amount of code. All you have to spend on is the electricity bill on this DGX computer. I want to show you some other specifications. For example, it has 6144 CUDA cores. When you have a regular laptop, the CPU cores will be 2 or 4, correct? Here it is 6000. It's like it has 6000 brains. It all works in parallel. And then it has CPU cores 20. So it's a unified architecture. CPU and GPU is like in one chip. And then it can run AI models up to 200 billion parameters, folks. It is so powerful. That's it, folks. In the future videos, we are going to make some more experiments. We will go through some of these use cases that they have mentioned. You can do fine-tuning of your models. You can do fast inference. You can run Hermes agents with local models. You can have CLI coding agents, all of that. See, you have so many amazing use cases which you can run on this local computer. All right. Thank you very much for watching. If you have any questions, please post in the comment box below.